Hey guys, in this lesson we're looking at using theorems for two parallel lines and a transversal. So we're going to take all that vocabulary we worked with in the last lesson and apply it to parallel lines and show how they work and rules that we can use with them. There's two big different main types of rules that we use in geometry. The first one is a postulate. A postulate is a rule in geometry that everyone agrees works and doesn't have to be proven or shown how it works. It's kind of like an undefined term, but it's more of an undefined rule. In order for geometry to be able to work the way it does, postulates are just accepted as true. And then we also have theorems. Theorems are rules in geometry that have been proven and can be proven to work. And we usually use our postulates to prove that these theorems do work. So postulates are things that we just accept as true. Theorems are things that we can show and prove are true. First rule that we have is the corresponding angle postulate. So this is one rule that everybody just accepts that works, and there's really no way to show that it definitely does work. It tells us that if we have two parallel lines cut by a transversal. So notice they got specific with us. In the last lesson, they just said if we had two lines. Now we have to have parallel lines. And whenever you look in pictures, you'll see these little arrows right here. Sometimes they'll make them bigger and they'll look like this. But that's how you know for sure that you've got two parallel lines. So if two parallel lines are cut by a transversal, then the corresponding angles are congruent. So you can start seeing how that vocabulary we worked with in the last lesson is going to be super important to know. So if we look at what we've got, they tell us if we have two parallel lines. So there's one line, there's the other line that's parallel, and if those two lines are cut by a transversal, so there's our transversal, then the corresponding angles are going to be congruent. So remember, correspond is on the same side of the transversal, on the same side of the line. So if I start over here with angle 7 is going to correspond with angle 1. So that's what we talked about last lesson, just being able to identify them and pick them out. This lesson is going to tell us the actual value relationship between those two angles. So here they tell us that they're congruent. So that means if this is 23 degrees, angle 7 is 23 degrees, angle 1 is going to be 23 degrees. So, and we can do this for all the angles in our picture. So if angle 7 is going to be congruent to angle 1, because it was above to the left, we've got, let's go, angle 8. Angle 8 is going to be congruent to, got to find the other angle that corresponds to it, and I'm going to use these little arc marks, and I'm going to use 2 because now we're talking about that angle right there. 1 for this angle, said these two are congruent. I'm going to use 2 for the one that matches up with 8. So 8 is to the right and above, so to the right and above, there's this angle 4. So angle 8 is going to be congruent to angle 4. We haven't talked about angle 6 yet. So angle 6 is to the left and below, to the left and below is angle 2. And according to this corresponding angle postulate, this is the rule that tells us that they are going to be congruent. So that's the third set, so I'm going to use 3 arc marks. And then what's left, angle 5 is going to be congruent to angle 3. Okay, and there's our corresponding angle postulate. Looking at the next postulate we have to talk about is our alternate interior angle theorem. So notice this is a theorem. If we wanted to, we could take the time to show that it works, and we would actually use our corresponding angle postulate to prove that it really does work. But we're just going to focus on remembering the rule and how it shows that relationship between those angles. So for our alternate interior angle theorem, if two parallel lines are cut by a transversal, notice we have to have the parallel lines and we have to have the transversal or this rule's not going to work. Then the alternate interior angles are going to be congruent. So if we find our things, we're looking at two parallel lines. So there's one line, there's another line, And again, right there is that symbol that tells us that they are parallel. They could have also told us that line, it's line M is going to be parallel to line M. They could also actually tell us with the line names instead of putting the little arrows in the picture. So that's another way they could tell us. So if we have two lines cut by a transversal, so there's our transversal, then the alternate interior angles are congruent. So there's interior, so that means we're looking for these angles right here on the inside. So alternate interior, we're looking at angle 8, and then the one that alternates with that is angle 4, and this theorem tells us that they are congruent. But that's not our only set of alternate interior angles, so I want to make sure to list the other one as well. We've got angle 5 is congruent to angle 1. All right, so the next one we have is our alternate exterior angle theorem. So that tells us that if we have two parallel lines, one line, two lines, so we do have the two parallel lines cut by a transversal, and again there's those little symbols that tells us that they're parallel, then the alternate exterior angles are congruent. So we're talking exterior, so we're talking about the angles out here, and we're looking for alternate, so they want to alternate about the transversal. So angle 7 and angle 3 are our alternate exterior angles, and the rule tells us that they are congruent. So we've got 7 is congruent to 3, and then our other ones are going to be angle 2 is congruent to angle 6. There's our alternate exterior angle theorem. Next one we have is the consecutive interior angle theorem. This one tells us that if we have two parallel lines, one line, two lines, there's their parallel, cut by a transversal, then the consecutive interior angles are supplementary. So interior means we're looking at that angle right there. And it wants our consecutive interior angles. Remember, consecutive means the same thing as same side. So if we're looking on the same side interior angles, I've got angle 1 and angle 8 are on the same side, that left side of the transversal on the inside. And it tells us here that they are supplementary, so that we need to remember what supplementary is. Supplementary is two angles that add up to be 180 degrees. And this is probably the most important part of that definition. Yes, it's really good to remember that supplementary means 180, but specifically and most importantly, it's two angles that add up to be 180 degrees. You have to have two things at least to add up to be 180. So if we do that, well, here's our two angles, angle 1 and angle 8. If we add those together, they should add up to be 180 degrees. We have another set of consecutive interior angles, and notice I'm not going to use the arc marks that I did above. The arc marks say that things are congruent, and I'm not saying angle 1 and angle 8 are congruent. I'm saying they're supplementary, so I'm not going to use the arc marks to show that they are related. But if I show the other sets of angles that are supplementary, we're looking consecutive interior, so angle 5, angle 4 are supplementary, two angles, 1, 2, that add up to be 180 degrees. Well, if we can do consecutive interior, we can do consecutive exterior angles. So again, we have to have two parallel lines. If we don't have two parallel lines, this isn't going to work. So there's one line, there's another line, and I'm double checking, yes, they are for sure parallel. And then in addition, they have to be cut by a transversal. There's our transversal right there, and the transversal has to go through at least two different spots. Then the consecutive exterior angles are supplementary. So exterior means we're looking at these outside angles right there. So consecutive means same side. So if I'm looking at angle 7, I need an angle that's on the same side on the outside. So angle 2. And it tells us that they're supplementary. And remember, supplementary means two angles that add up to be 180 degrees. So one angle, two angles add up to be 180 degrees. And if I get my other angle pair in there, so there's those, we did those. So if we talk about the other ones, we're looking at angle 3 plus angle 6 is going to add up to be 180 degrees.